This lesson is angles and segment lengths formed by chords, secants, and tangents. So we're going to solve problems using angle and segment lengths. Okay, so the first thing let's do is let's talk about just some basic stuff. So when chords, secants, and tangents intersect in a circle, on a circle, or outside of a circle, special relationships exist between the angle and arc measures formed. So if you'll notice, here are two chords. They are intersecting inside a circle. Here is a tangent and a secant intersecting on a circle. And then here are two secants intersecting outside a circle. So that's what it's talking about. Okay, so if you have two, well, it really doesn't matter what it is, two things intersecting inside a circle, we have a theorem or a little formula. So if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So that's a mouthful. Let me show you what I'm talking about. So the measure of angle 1 right here, angle 1 would be equal to 1/2 the measure of AD, so that intercepted arc that's inside the angle, plus the measure of BC, so the one that's directly across from it. Alright, also you could do the same thing for angle 2. So if you wanted to do angle 2, it's going to be pretty much the same thing. It's going to be 1/2 the measure of the arc it's intercepting, so the measure of AB, plus the one that's directly across from it, so DC. Alright, so those are your formulas. 1/2 of the two arcs across from each other added together. Alright, so let's use that, and we're going to do this one really quickly. So I want to find AED. It's right here in green. So I'm going to have to do 1/2 the arc inside, 45, plus the arc directly across, 109. And I just put that in my calculator, and I get that it is 77. Okay, so we're going to do the same thing with the next one. It's a little bit different, a little more challenging. So we are trying to find this major arc CDE. So the measure of CDE, if I add it to the arc directly across from it, then 1/2 of that should equal this angle. So it's that exact same formula, you're just kind of working backwards in this case. So what I would do is you could divide both sides by 1/2 if you wanted to. And just be careful when you do that. If you type like 128 divided by 1/2 in your calculator, you have to put 1/2 in parentheses or you won't get 256 like I just did. Alright, and then the last thing I'm going to do is I'm going to subtract 73 to the other side. And so I get 183 would be the measure of major arc CDE. And then don't forget little simple stuff, like if there's 3 letters, then it's going to be a major arc, which is more than 180 degrees, which it is, so we probably did it right. Alright. Okay, so now let's look at what happens when you have intersections on the circle. Okay, I think these formulas are a little bit easier than that one we just did, but you can be the judge of that. So, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half of the measure of its intercepted arc. Blah, blah, blah. Here's what it's saying. If I want to find the measure of angle 1, then what I'm going to do is 1/2 the measure of the arc inside the angle. So you have to make sure you're doing the one inside the angle. So that one would be arc AB. Similarly, if I wanted to find like angle 2 would be equal to 1/2 the arc inside that angle, which would be BCA. Okay, so it works the exact same way. Just make sure that you're talking about the arc inside the angle. That's what I've seen some people do incorrectly. Okay, so we're going to find this one. We are trying to find the measure of DEG. So that's going to be equal to 1/2 the arc inside the angle. This is the arc inside the angle. And it tells us it's 308. Oh, that's 38. 308, there we go. And I'm just going to type that in my calculator, and I get 154. Okay, so if you look in the next one, I'm trying to work a little bit backwards this time. I'm trying to find the arc KNM. So 3 letters, so you're finding a major arc has to be more than 180 degrees. Okay, so if we wanted to find that arc, then we need to be referring to this angle. Alright, we know that this little one is 23 degrees, but we know that a straight line has to equal 180. So if I do 180 minus 23, I'll get that orange angle. So that would be 157. Okay, so I wrote the formula out. 1/2 of the arc is equal to the angle. So what you could is divide both sides by 1/2 or multiply both sides by 2. But either way, you're going to get the measure of KNM equals, 314. And it's a major arc, so we probably did it right. Okay, moving on. Alright, the next thing we're going to look at is what happens when you have intersections outside of the circle. And these are a little weird. I'm going to go ahead and write the formulas, and then I'm going to color code stuff and talk to you about it. Okay, so if you'll notice, all 3 formulas are exactly the same. So it's 1/2 of the big arc minus the little arc. So the angle outside, I should have done that in another color. This angle A, the angle outside is always going to be equal to big arc minus the little arc. And all of those arcs have to be inside the angle that it's making. So it looks like a lot, but they're actually the same formula just over and over and over. Okay, so let's do some problems. Okay, so we want to find the measure of BCD, which is that little angle outside. And we're going to do the big arc minus the little. So it's going to take a little bit of math for us to get this, because it doesn't actually tell us what this orange arc is. But we know that 67, 94, and the orange arc are making a semicircle. So that all 3 have to add to give you 180 degrees. So if I do 180 minus 67 minus 94, I get 19 degrees. So here's my formula. The measure of that outside angle is equal to 1/2 the big arc, 67, minus the little arc, 19. I put all of that in my calculator, and I get 24 degrees. Okay, so I want you to try the next one. It's the same formula, but you're working a little bit backwards. So I want you to pause the video and see if you can do it. 1, 2, 3. Okay, so here's how you set it up. The angle outside equals 1/2 the big arc minus the little, which is what we did. Alright, so I set it up for you. I color coded it just like we would. And now we're just going to work backwards. So I'm going to multiply both sides by 2. So I get, let me change my color, 112 equals, I don't need the parentheses, 160 minus that measure I'm looking for. Okay, I'm going to subtract 160 to the other side. It's going to be a negative number. It's perfectly fine. And this is just like if you had like a -1 in front of an x. If I divided both sides by -1, I get the measure of MK has to be 48. Okay, so hopefully you got the same thing I did. If not, it's cool. We're still practicing. Alright, and then one last thing we're going to look at. These are segment links formed by intersecting chords, secants, and tangents. So I'm going to go ahead and write the formulas out, and then we'll talk about them. Okay, so these are pretty annoying. you're very unlikely to see this on an ACT or something like that. We don't even use them in Math 3 that much, but I do have to show it to you because it is in your curriculum. So I'm going to color code it, so hopefully you can see where these are coming from. So AB are the two making the chord, and then CD are also making the chord. So if you multiply those together, they have to equal the other two multiplied together. Type 2, if you had two secants outside, A would be this one, and B would be right beside of it. So then this one's C, and this one's D. And you can see that A and C are outside, B and C are inside the circle. And then the last one, if you had intersecting a secant and a tangent. So A is going to be your tangent, and then B and C are going to be your secant, and they're going to be right beside of each other. Alright, this is my least favorite of the entire Math 3 circles unit. So we're just going to do a few problems and get this over with. Alright, so I want you to just pause the video, and I want you to figure out which formula you would use and see if you can go ahead and set it up. So try that in 1, 2, 3. Okay, so the two beside each other, 27 and x plus 5 are going to be multiplied, and they're going to equal the other two beside each other, 24 and x plus 7. And now we're just going to, this is just normal math stuff, we're just going to distribute and get our like terms together. So go ahead and pause the video and distribute it and get your like terms together. And then the last thing you're going to do is divide by 3. So x equals 11. So not too bad, but the formulas are super annoying, so I'm sorry. Alright, if you'll go ahead and try this one, pause the video, see if you can figure out the correct formula, and see if you can set it up. 1, 2, 3. Alright, so hopefully this is how you set it up, and now I'm going to distribute, and I'm going to get my like terms together, so you can pause the video and try it. The last thing I would do is divide by 13. I get x is 27. So the question asked me to find NL, so now I would just plug 27 back in here, and 27 plus 13 is 40, so 40 is going to be my final answer. Alright, let's do another annoying problem. So see if you can pick out the correct formula, and you can set it up. 1, 2, 3. So hopefully this is what you got. Remember that, whoa, that looks like a butt. Hold on. That anytime you have x plus 5 squared, that means to do x plus 5 twice. So hopefully you realize that you need to FOIL that together or distribute it. So when you do that, you can try it, but you're going to get this. Hopefully you also realize this is a quadratic. You always want quadratics to equal 0, so I'm going to move that 324 to the other side. And then I feel like we beat this horse to death. And this is a quadratic. You can solve it by factoring, by graphing, by the quadratic formula. So go ahead and pause it and try to solve it whatever way you want to. Try it in 1, 2, 3. So I solved it by factoring. I got x plus 23 and I got x minus 13. I take my factors, I set them equal to 0. So I get x equals negative 23. And I get x equals 13. So if I were to plug this one back in to right here, I get a negative answer, which doesn't make any sense. So this one is going to be my only answer. Okay, so that was just some algebra stuff. Try your assignment. I know this unit is difficult, so ask me as many questions as you need to. And I will talk to you later. Bye.